Viewers like you make this program possible. Support your local PBS station.
This is the story of energy, humanity's single most important resource. Energy is the force that built our modern world, but it's often invisible to us, hidden in plain sight. Before modern energy, people had to walk miles to get water, carrying it by hand or on their head. With a modern energy system, we can move water with an electric pump, freeing up precious time. Once water is plentiful, we can grow abundant food. And with abundant food, there's extra time for education. Educated people have access to economic prosperity. Some can even operate a business and accumulate wealth. With money, more people move to cities where there's more to do. Cities need transportation to bring goods back and forth. And people are more likely to travel to see the world. All of these luxuries give us a quality of life worth protecting and even fighting wars over. As a society, we're making decisions about energy that will impact our planet for centuries. So we must understand it. And we can understand energy by looking at food.
The way our society is structured, the processing of food becomes very invisible. It's distant from us.
Energy availability has been a critical issue for this food supply that not only feeds our own growing population of now 325 million, but also an enormous export option as we feed many across the world.
So if we look towards 2050 and that we need to be able to produce twice as much food in order to sustain that population, everyone's going like, how are we going to achieve that?
What we are confronted with right now is a tripling of human population, no increase of water, land, and so on, while at the same time, an immense waste challenge. We are wasting about 40% of the food produced today in the world, not just in the United States, but globally.
While we're searching for solutions to our climate challenge, a lot of people expect that technology and new innovations are going to get us there, when in reality, if we address food waste now, there'll be a lot of change that we can do without having to invent our way out of the problem.
When you think about what it takes to grow, transport, cool, cook, shop for, get it back to your home, everything it takes to get food to our tables, there's an enormous amount of energy built into that process. It's primarily fossil fuel energy.
10% of our national energy consumption is embedded in the food system. We have more energy embedded in the food we throw away than Sweden uses for all purposes over the course of a year. You could run entire countries on the energy embedded in the edible food that we did not eat. It's really incredible. The scale is hard to understand.
I think another way of looking at waste is that it's actually wealth. So how do we not see it as something that's unnecessary? But we re-examine that waste as, okay, what context is that waste wealth?
This is Power Trip, the story of energy. This is a remarkable story of progress, as so few people can feed so many. Developed countries with modern energy went from food scarcity to food abundance. But there are more than 1 billion people who still don't have enough food. And richer countries now have a food waste problem because of all the excess. That's why food is a critical chapter in the story of energy.
Je m'appelle Laurent Petit, restaurant Le Clos d'Essence à Annecy-le-Vieux, 2 étoiles au guide Michelin. Je suis là depuis 1992, où j'ai créé ça avec ma femme. Donc tout d'abord d'une cuisine avec les codes classiques de la gastronomie, tout ce qui comporte tout ce qu'on trouve classiquement dans la gastronomie, c'est-à-dire des produits qui viennent de partout. Sauf que depuis 4 ans, j'ai fait ce que j'appelle mon cooking out. Voilà, et j'ai vraiment décidé que tout se passerait simplement autour de moi. Il n'y aura bien sûr aucun entrant, aucun pesticide, aucun traitement, aucun entrant. Okay, et l'eau, c'est l'eau de récupération du toit. Voilà, avec tout un système, il y a une cuve de stockage. Et après, on redistribue avec tous les tuyaux. Il ne faut surtout pas arroser par-dessus. Okay, la plante va chercher au fond l'eau. Et donc là, elle va se donner de la force et les saveurs seront vraiment meilleures. Ça décuple les saveurs. C'est-à-dire que l'eau, pour moi, est l'ennemi du légume. Je donne de la saveur à mes légumes uniquement en faisant rôtir. Et après, ça c'est une cuisson très lente, tout doucement comme ça, qui va rendre le légume très moelleux, très fondant. Et après, pour lui donner une ligne directrice, pour qu'il ait du corps, du nerf, on va colorer le produit. C'est un tout petit restaurant. Et ce que vous voyez aujourd'hui, c'est le résultat de bientôt 26 années de remise en question perpétuelle et d'avancée perpétuelle.
The story of modern energy in our food system begins with water. Moving water to irrigate our crops has been a part of the story of civilization for thousands of years. In the past, humans had to dig ditches to bring water in for crop irrigation. And some ancient societies built aqueducts that moved water to fields using the force of gravity. Humans used their muscle power to work the field. Eventually, animals could be domesticated to help grow food more quickly. Oxen and horses pulled plows or carts and worked devices to pump water or grind grain. Their manure was used to fertilize the crops, and cats were used to rid the fields of mice. Today, nearly all of those functions have been replaced by modern forms of energy. Our global food system is now dependent on petroleum, natural gas, and electricity. Today, there is modern energy embedded in every bite of food we eat.
Feels like everything in the story of civilization begins with water. Energy is tied in with water because we can use energy to move water and treat water. And then if we have enough energy and water, then we can have food. If we go back a couple hundred years, before we had all the energy available to put into our food system, hunger was much more common. They didn't have as much food, and they didn't always know where the next meal would come from. They also often would have to grow their own food. They'd have to be part of the process of gardening or farming to get the food.
For most of our agricultural past, people were immediately tied to food from the moment they were born. Farming was just part of how we lived, and today less than 2% of Americans live on farms. We are more removed from agriculture than ever before.
The industrialization of food changed that.
Hi, how are you doing? Good, I'm ready for lunch. Because of the modern energy system, we can have things like this 5,000-mile salad, where the different parts of it came together from around the world, all for my convenience and taste. We grew the food using fertilizers made from natural gas. We harvested it with machines using diesel. Then we ship it or truck it to a central facility for processing and chopping and wrapping it in plastic made from fossil fuels. Refrigerate it with electricity, maybe made from coal or maybe solar power or something like that. So there's all these different forms of energy that come into the salad to bring it here together at this time, just so I have a nice, healthy lunch.
Reliable water was a key to food abundance, and food abundance enabled stable societies. A stable society can take on multi-generational challenges. Perhaps because of a stable food supply in Europe, leaders could decide to launch ambitious projects like the construction of cathedrals over hundreds of years. Many of those remarkable buildings still stand today as testaments of the powerful and lasting effect of food abundance.
Food and energy go hand in hand because food is a form of energy. Food is the form of energy our bodies use to operate as muscles. And we're like a power plant, and food is the fuel for our power plant. And food is grown with energy, primarily solar energy. Sunshine comes in, and that is captured by plants through the photosynthetic process. Photosynthesis takes CO2, water, nutrients, and sunshine, and turns that into stored energy in the plants. And plants are at the basis for our food system because even the proteins, like animals or fish, eat those plants. So we're all eating solar energy in one form or another.
Just as the availability of modern forms of energy revolutionized our access to water, the food system was revolutionized by diesel for tractors, oil and gas for fertilizers and insecticides, and electricity for refrigeration. Energy liberated us from the shackles of manual labor and reduced the unpredictability of nature. Energy made our lives easier. One consequence of modern energy in our food system was a green revolution in the 20th century that transformed agriculture and caused farm productivity to grow exponentially.
When people used to grow one crop in one place for many rotations, you would deplete vital nutrients to the soil, particularly nitrogen. So through crop rotation, we would be able to overcome that challenge, and you could increase the amount of food that could grow in that space again. Usually they would rotate 2 different crops with some kind of legume, and that would put the nitrogen back in the soil, make it a lot more productive, and you'd increase your yield again.
That 3-crop rotation increased agricultural productivity significantly, and that was transformative. But at some point, even 3-crop rotation could not keep pace with the food demands of these booming societies and these growing cities. It became an issue where we couldn't get enough food to feed ourselves. The mechanization and industrialization of the food system, such that it used more energy, took place really over several decades. Mechanization increased the productivity of agriculture dramatically. It meant more area of farm could be planted and harvested. It meant more food could be moved to market. It meant productivity went up a lot.
There was a point in the early 19th century where farmers were going to war. World War I and World War II happened. It was clear we needed more food, our populations were going up, but we were losing a lot of the farmers and a lot of the ability to keep producing food at the scale that was necessary.
During the early part of the 20th century, German chemists developed a breakthrough industrial process that allowed crops to be fertilized on a massive scale, powered by modern energy. The Haber-Bosch process is the industrial process that allows for the manufacture of ammonia from hydrogen and nitrogen, only made possible by a series of chemical reactions powered by fossil fuels. This was transformative for agriculture because it enabled more crops to be grown per acre. Farmers no longer had to rely on manure. Crops grew faster and were often healthier. This new energy process had other uses. In Germany, the other major use of ammonia from Haber-Bosch was in making explosives. Following the end of World War I, Germany attempted to keep the Haber-Bosch process a secret. But the French soon received the technical details they needed to build their own plant. The French began producing ammonia in the early 1920s, followed by the British and the Americans. Later, these German chemists were honored with 2 Nobel Prizes.
The Haber-Bosch process takes natural gas, primarily methane, and converts it to ammonia, which can then, in a liquefied version, be applied to soil, and suddenly there's a lot more nitrogen, and that soil can be far more productive, and we get more food at a point that we need it.
But the mechanization didn't stop at the farm. It also continued in the processing, at the factories, at the mills. When food production started to grow at large scale in the late 1800s, large cities in the Midwest and Great Plains of the United States popped up, based on their transportation networks or because of their ability to process the foods. And Minneapolis, Minnesota is one of those cities.
When it really boils down to it, there's nothing terribly unique about making flour. the Egyptians made flour 5,000 years ago. By the time the Greeks and the Romans came along, they had that sort of thing. So that was 2,000 years of human progress. You're not going to make 2 million pounds of flour a day in that sort of vessel as they made when this mill was operating at peak capacity. So you had to have something else. So they used steel rollers when this mill was operating. So here's a very small tabletop wheat grinding roller.
See the rollers in
there are 2 rollers inside there. Here's wheat. This is the seed of the wheat plant called a wheat berry. The wheat berry is like an egg. It's got 3 parts: bran and germ and endosperm. When this building was built in 1880, most people who were considered nutritional experts believed that flour should be pure and white.
So this is mostly what we eat is the endosperm.
That's correct. In the middle of the 19th century, only rich people could afford white flour. It was very difficult to make because of the repeated sifting that was necessary to make it. Poor people ate brown bread. So what made Minneapolis the milling capital of the world is they figured out a way on an enormous industrial scale to create huge amounts of pure white flour, which dramatically reduced the price and made it available to everybody in the world. So we don't have all of the machines in this little top display to make pure white flour, but we can make a little bit of flour nonetheless. So the 2 grinding wheels that are inside there, you can be the Mississippi River for us today.
You can see the wheat berries kind of coming through slowly like an hourglass. That's not quite big enough for them.
And then you have to put it through a sifting process. So the broken open wheat drops on the top screen.
And what do we start with?
It was maybe a quarter cup or so,
cup,
yeah.
okay.
In the mill, the machines were actually kind of shaking. So the stuff that doesn't fit through this top screen is eventually going to shake off.
Okay.
And it'll go through a tube down to another grinding machine.
You see it's already whiter than the top layer. Flour's getting whiter as it goes down. Even whiter, finer. Look at that. There you go. That's, I don't know, a teaspoon or something.
Yes.
How much do we need to make a cupcake or a muffin?
Well, a couple cups.
A couple cups, so we got a lot more grinding ahead of us.
That's right.
Teaspoon and a half, maybe 2 teaspoons. Why stop now? This is slow work. My back is a little sore. I'm a little tired. It's a lot of work to get high quality flour. So I just spent 15 minutes, however much time it was to grind this, to get a couple tablespoons maybe. What can we make with that? Is there any dish small enough?
Flourless chocolate torte.
Flourless.
For millennia, water was used to irrigate crops and provide the power for milling grains. In that way, water helped to produce food on an industrial scale. Tens of thousands of water wheels across Europe helped crush grains, one of the basic building blocks for food. The growing global population increased demand for food, which increased the need for water power, ultimately giving rise to industrial city centers situated on rivers, like Minneapolis. Major food companies located their mills in Minneapolis because it was close to the grains from the Great Plains of the United States, but at a point where water power was steady and available along the powerful Mississippi River.
The Falls St. Anthony were used for the water power to power the sawmills and flour mills that made it the mill city. You can see it's about a 50-foot drop right here. It's the only place along the entire length of the Mississippi River where a significant drop occurs.
Falling water on the Mississippi River at one location gave the water power that was necessary to operate really big mills. And that meant Minneapolis at one point was the world's largest milling center.
Milling goes back to the earliest civilizations. But here is a culmination of water power, transportation systems, and new technologies for milling flour that enabled them to scale it up to not just selling for a local market, within a few dozen miles, but selling it around the country and eventually around the world.
Mechanization increased the productivity of agriculture dramatically. We once used water power to grind grain, used the energy of the flowing water to turn the wheel that would grind the grain. And with modern mechanization based on fossil fuels, you could do the same thing, but you didn't have to be next to a river. So that mechanization meant we could produce more food and process more food more cheaply.
Behind me is the entrance gate to the Union Stockyards. Imagine you're here in 1865. This gate set off the entrance to hundreds of acres of stockades and pens. It would have smelled to high heaven. There would have been blood running in the streets, manure and all sorts of mess here. It was a dirty, filthy, but highly profitable and productive place.
The meat system gives really high value proteins. It gives foods that have nutritional value that the other foods do not have. And in many cases, if done the right way, those cattle are eating grasses that we can't eat. They're taking inedible, low-quality bioenergy, grasses, and turning it into a really valuable, high-energy protein. So all this energy was put into the system to increase productivity and then to avoid loss. And as a consequence, fewer farmers today can feed the whole nation. That's because of all the additional help they get from energy. All the foods require energy, land, and water. And some foods require more energy, land, and water than others. It takes a lot of grasses to feed a cow. And that means the meat system is much more energy intensive than the grain system. So the meat system is very impactful, and then it produces a lot of manure. And that manure is a waste product that we have to manage.
So this is one of the oldest barns here at UC Davis. It's about 100 years old. It's made from redwood. So this is one of my favorite places on campus. This is where the feed was stored up here. This is how my academic ancestors traveled across the campus here 100 years ago. So while we are in one of the oldest barns on campus, these are the youngest ones or the newest ones. What they allow us to do is measure the environmental impact basically of livestock that's housed in groups. So we can have 14 or so cattle inside each one of those so-called bovine bubbles, and they just live their merry little lives. But while they're doing that, we are measuring the environmental impact. My name is Frank Mittlöhner, professor and air quality specialist in the Department of Animal Science here at UC Davis. These are Holsteins. Holstein Friesians are the #1 dairy breed in the world. A cow like this might produce 25,000 pounds of milk per cow per year. In a country like India, the same breed cow will produce 1,000 pounds. There is a PhD nutritionist who formulates these diets for all cows in most dairies in this country. So they are eating a more balanced diet than you or I guarantee you. We need to do research on different fronts. The one is reducing food waste, clearly. The other one is how to produce food more efficiently. Ruminant animals have to eat large amounts, and then they stop eating and start what's called ruminating, okay? They're chewing the cud, and that means they're bringing what they previously ingested back up to chew it again and make it into smaller particles. And during that process, a lot of the gas that's generated while the microbes in the stomach digest it, those gases can escape, and that's called belching. And the reason why anybody cares about that is because a good chunk of that belched gas is methane.
Methane is a greenhouse gas, and greenhouse gases go into the atmosphere and they trap heat. And then that exacerbates the effects we're already seeing from climate change.
Before we had feedlots, cattle were actually on pasture their whole lives. The grass-finished animal will have much lower energy use, there's no doubt about that. But they are producing more gaseous emissions. California has a new law, it's called SB 1383, or the methane law, and what it requires is a 40% reduction of methane to be achieved by the year 2030. Now the big problem is, farmers who want to know, well, how much do I need to reduce, ask me, the scientist, what is my dairy emitting today? Problem is nobody's ever researched that. So these are so-called head chambers. They allow us to measure the belched gases from cows. We're not interested in the farting. The farting is not important. The belching is the important part. So the animal has water and feed available. All the gases expelled through belching and breathing are then captured because the gases go from in here through a pipe system into gas analyzers and then are measured instantaneously. So our farmers are hungry for that type of research because they are now under the gun to reduce methane and reduce it fast. So there are two main sources of methane coming from mainly cattle. The two main sources are enteric emissions, and that's the rumen of those animals. The other one is waste-related methane. One can take the manure that's produced on livestock farms, and one can capture that methane. For example, with what's called an anaerobic digester. Imagine a dome over an animal manure facility, capturing all the gases that come off that manure. And then you can do two things with that methane gas. You can either burn the gas and make power from it, or you can take that biogas that contains all that methane and make fuels from it. On the feeding side, you have feed additives, for example. You can feed to the ruminant animal, and it disrupts the formation of methane in the rumen. In agriculture, we have a lot of byproducts, parts of crops that we don't eat, okay? So think of, let's say, producing cotton, like the shirt I'm wearing, okay? Cotton also produces these seeds. They're called cotton seeds. They're very high in protein, very good cow feed. This year is from almond production. These are almond hulls. If we wouldn't feed it to cows, we would waste it. Everything in agriculture is so interconnected. There's a growing number of people, particularly in cities, saying, let's get rid of livestock because we are really wasting valuable resources. And they're wrong. Livestock makes use of an untapped resource that nobody else can. I'm excited every time I see that there are new processes that allow us to become more efficient.
One of the challenges with food is that it can spoil. Food preservation has been one of the grand challenges for humanity forever. There are a variety of ways to preserve food. One way is to dry the food, like beef jerky or dried meats. Another way is to smoke food, smoked meats and smoked salmon. That's a way to get the food to last longer. Another very common way was to salt foods, especially like salted fish and salted hams, that kind of thing.
Refrigeration was a milestone moment that changed everything. Suddenly food could be stored a lot longer, food spoiling, food safety, still an issue, but was also a lot more manageable. We were suddenly able to move food a lot more efficiently and safely and store it for later use.
But that took some consumer education, and over time, we've gotten there. We now eat foods that are from far away that have been packed and frozen or refrigerated, and rarely eat freshly butchered meats today.
If this competition is to do the best for both of our peoples and for people everywhere, there must be a free exchange of ideas.
In the middle of the 20th century, there's a famous kitchen debate between Richard Nixon and Nikita Khrushchev, the premier of Russia. And this was a clash of cultures, capitalism versus communism, democracy versus autocracy. And Nixon and Khrushchev had this impromptu debate in front of a kitchen at an exhibit at the World's Fair. And it's important that that debate took place in the kitchen, because it's at the kitchen where food comes to the plate, where we have our highest expressions of our ideals or our sense of family or our sense of culture. Richard Nixon talked about all the appliances that we had that made life easier for women in particular. And Khrushchev mocked this, said, well, hard work is a good part of the character, and why haven't you invented a machine that chews the food and pushes it down your throat for you as well? This kitchen debate from decades ago still resonates in our popular culture today. With industrialized food production, we have more food available with fewer people and at a more affordable cost. That is the amazing impact of energy into the food system. A grown human adult will need about 2,000 nutritional calories a day just to maintain the function of their body. We have to get that energy to operate our bodies from somewhere, and we get it from our food. The food is a fuel for our bodies, and we need to ingest the right number of calories to keep our bodies alive. And it used to be we would spend our own calories and muscle power to make the food that we would then ingest. But now someone else is putting the calories in from natural gas or diesel that goes in the food that goes to our bodies, and we're spending our energy elsewhere. And the good news from that is that trade-off of energy for free time gives us some freedoms. We're liberated from the field to go pursue other things.
Michael Weber, nice to meet you.
Jeremy, nice to meet you.
Thanks so much for having Jeremy. So a normal college campus of 4,000 students, by normal I mean like a more conventional experience, those 4,000 students don't all eat at the same time.
That's correct.
They don't all eat the same food.
That's correct.
And it's not served buffet style.
This operation is unlike anything in the military. I've been involved in military food service for 22 years of my Army career, and I got here, and my first 3 weeks here of learning the operation, I felt like I was drinking from a fire hose. The tradition here at West Point is family style. That allows us to do certain things, namely the feeding of 4,500 cadets at one time. Fruit is exceedingly popular.
I'm sure.
We go through anywhere from 1,000 to 2,000 pounds of fruit a day.
A day? 1,000?
A day.
Okay, it's a ton, literally a ton of fruit
Literally
a
a ton
day.
of fruit a day.
Okay, I did work in restaurants for 6 years.
Awesome.
So I have some professional training. Hopefully I
Okay.
can help you replenish the fruits into the
Okay.
salad bar. I'd be happy to do that if there's a
Gotcha.
spot.
Your hat, sir. It's
Okay,
very
good.
fitting. So we actually make certain options available 24/7. This building never closes. We also have 2 salad bars located out in the dining area.
Okay.
And this is actually, it helps to necessitate the droves and droves of cadets that come through to eat every day. We make this option to try and squeeze the cadet, the entire core through the line, and we can get the entire 4,500 strong core cadets through the serving area in under 12 minutes.
That's amazing. As recently as 40, 50 years ago, we've had a cheap food policy in the United States. We've really promoted agricultural subsidies to make sure we have enough food, and for the most part, that's worked. In a place like the United States, it seems like we're obsessed with food now. We're worried about the art form of the food. Whereas if you go back 5, 6 decades, we were worried about having enough food. Our popular culture, consumed by the middle classes, is really thinking about the different ways you might prepare it and what does it look like and how to do it. So all these cooking shows that are very popular. I think that's a sign that a lot of our food access problems have been solved for the people who watch those shows. One of the trends underway in the United States is the rise of meal kit delivery services. And these are both good and bad like everything else. Meal kit delivery services use energy to deliver the meal kits to your home. You have the energy for the truck, but that truck might be delivering multiple meal kits to multiple people on your block. And then it means you don't have to spend energy in your car to go to the grocery store to buy that food. It might avoid a lot of traffic, it might reduce traffic congestion, it might save time, it might be very good from an energy perspective. And the meal kit is designed to have just enough food that you need for that meal, so it actually reduces waste. Packaging also matters. We have energy in the food itself, but then we wrap the food in packaging that also has energy embedded in it. It might be plastic made from natural gas, so there's all sorts of packaging around that food, and the packaging has a lot of energy, and sometimes there's more energy in the packaging than in the thing inside, like for a plastic water bottle, for example. There's a lot more energy in the plastic of the water bottle than there is energy in the cleaning of the water to treat it to drinking standard. In the modern energy system, we use more than just the sunshine. Those modern forms of energy have increased the productivity of the food system incredibly. And it's also created the ability to store the food for longer, give us more flavors and more foods and more diversity all around the year. But it also creates abundance that leads to waste.
When we talk about food being wasted, it's really a systemic problem, and it's happening for a lot of different reasons at different points in the supply chain.
I think it is a very important discussion that we optimize our food supply chain. There are some food-producing areas that are already very efficient, and there are some where we are very wasteful. For example, vegetables and fruit are wasted at a 50% level, and it's unacceptable that we're wasting so much of it.
We need to be less resource intensive in providing the nutrients that we need for a healthy diet.
So there are a lot of, I would say, like hidden costs of the embodied energy and the embodied resources to pull it all the way through from the farm really to our tables.
These issues are all intertwined, and sustainability of that system, especially as we go towards maybe 10 billion people at mid-century, is going to be a very, very critical issue for the next 3 decades.
We waste like 25 to 50% of our edible food. In a country like the United States, where we have a lot of food waste, the place to start is to reduce the food waste.
Generally speaking, when you look at the footprint of food, the vast majority of the energy use and greenhouse gas emissions wind up being in the production of the food itself.
As the population grows, but the farmland doesn't, it puts pressure on us to manage farmland more wisely. Singapore is a landlocked nation, so they must take their food system very seriously.
Singapore's land area is just 721 square kilometers. So beyond just being a city, we are also a country. So this means having to support varying needs of the population, ranging from housing, transportation, the economy, industry, parks, recreation. So you get the whole range of it.
Farming is a big priority for Singapore. As a city-state, they don't want to rely on other people or regions for their foods. They want to be as self-sufficient on food as possible. And if you're a place of limited land, efficiency with food growth is important.
Essentially, what we want to do is to create an environment which is very comfortable for everyone to live in, where everyone knows the importance of saving energy, saving water, trying to move around either via walking or cycling, and use more public transport. Whenever we design our flats, we design our towns, we design our cities, we're always planning for the future.
They can't just do farming the way other people around the world do in terms of using a lot of sprawling land to grow their food. So finding ways for efficiency is really important, and that might mean new things like indoor farming.
This aquaponics system, we cannot use chemical at all, because the moment we spray pesticide on the vegetable, we kill all the fish. So it's a system that ensures no fungicide, no chemicals on our vegetables. The number of farms in Singapore is decreasing because of shortage of land. We are a small island. The government is promoting farm with higher tech. Aquaponics is a whole system that we feed the fish, and the fish will produce a fertilizer for the plants. And the plants that extra, we feed back to the fish again. We grow this for our restaurants.
For your restaurant?
Yeah.
What is this plant you're growing here?
It's rosa.
Rosa, okay.
Yeah. And the fish, they love vegetables. You see?
They're hungry. Can I do this also?
The lower one for the fish.
I see. The upper ones are for the restaurant?
Yeah, for restaurant.
See, they'll come up. But look at that big mouth. What kind of fish are these?
These are tilapia.
Yeah, tilapia. And then you can grow them for meat as well, sell the fish, right?
We sell the fish in the restaurant as well. Oh, it's a big catch.
So this is your restaurant?
Oh, yes.
And it's attached to your aquaponics greenhouse and your farm?
Yes. Take a seat here.
Great, thank you.
Take a seat here. And now we have some food here. So this is our salad that salad grow in the farm.
Yeah, we just saw this. You grow that.
Yeah. Okay. And then this is naibai, is a Chinese cabbage here. And these are fresh mushrooms.
Okay.
Chickens, but we don't grow them here. And this is kailans. They are also grown here.
And this you grow here also?
Yeah, all grow here. Yes.
This looks incredible. Yeah. So I don't think I've ever had food quite this fresh.
That's how you took some more fresh. We just pick from the farm.
Just 30 yards away, just very close by.
Yes.
All right, now you get to see how well I eat with chopsticks.
Go ahead. Yeah, go ahead. Okay. See, just with the tip, you can just hold it up. See.
So a little better.
Yeah.
Okay.
Just go with the tips. The salad is go with sesame cream.
Sesame
sauce. Yeah, sesame. Yes.
This is really good. Thank you. Cheers. Thanks for having me over.
Yeah, thank you. Yeah, cheers.
The amazing thing about the energy we use for food is that just a few people can feed 100 people. It also means we're morally, physically, and emotionally and spiritually detached from our food. So we don't understand where it came from or how it's made and what that means for us. So there's a separation that can invite some other problems. We probably don't respect the food system enough because we don't understand it.
I think that's exactly what we need to be thinking about. You know, at a philosophical level, at a spiritual level, at a moral level. One of the ways might be to really see the impact of food running through the process. The planting of food, how much water do we use, what kind of pesticides do we use? Every object that we create should have an understanding of, how much energy has been put into it.
My name is Yash Lee. I stay in Hougang, which is a part of Singapore in the northeast area. In Singapore, we call this like the Housing Development Board flats. Basically, it's 10 over stories high, tons of people staying in one block itself. So it's a small little apartments like this. What you're seeing behind me, this is my living room space. Basically, for growing plants at home, we tend to use soil, and in my house, I've been using water as the only base. And using a pump, it circulates the water. We add nutrient solution to it to ensure there's enough so-called fertilizers inside the water. And then the plants would be able to grab those nutrients from the water and grow by itself. To mimic the sunlight, we have the artificial lights, LEDs. By using this particular system over here, it's a much easier system for me. I don't have to water them every day. Just check the amount of nutrients inside, and I'll be able to tell if it's enough or not. Right now over here, you'll see some things like lettuce, mostly vegetables, and chilies, tomatoes, herbs. I do a lot of cooking, and with the fresh ingredients that I get, it's so much easier. Rather than going down to the supermarket, buying all the herbs and stuff, I just grab it off here, snip it, and use it straight. Basil is really good as pesto, or with mozzarella and tomatoes. Food is relatively cheap in Singapore, but still, because we don't grow them ourselves over here, we have to import them from Malaysia, Thailand, China. So the whole idea about growing this isn't actually about the price of food, but more of growing your own. It's just the same as going to a farm. You can pluck it off, chew it right on the spot, and it's pesticide-free. Oh, this packs a punch. I was told to increase the nutrients to get it sweeter. And after increasing it, this is what I get. Oh, I really wasn't expecting that.
One of the challenges is to keep foods from spoiling. And there are a lot of very healthy foods like fruits and vegetables that have limited shelf life.
We are wasting about 40% of the food produced today in the world, not just in the United States, but globally. And that's particularly bad for perishable foods, such as fruits and vegetables, which we waste at 50%. Meats and milk still at 20%.
Refrigeration has been one of the great changes in how we manage our food. On one hand, refrigeration adds enormous amount of shelf life to how long our food lasts. On the other hand, we've kind of adjusted our shopping habits and our food management habits to account for that. Generally speaking, we want to be eating fresh fruits and vegetables. That's what we're hearing is healthy for us, and yet those are the exact foods that go to waste most in our homes, refrigerators, and businesses.
Plants were never intended to last forever, for the purposes of human consumption. They're perishable and seasonal. The idea was really to be delicious, fall to the ground, be eaten by something, and have your seeds spread across the earth. Pluses and negatives to having produce basically be never out of season. As great as that's been for us as individual consumers, that also does mean that there's a price to pay because it's very intensive in order to support that kind of a system. In the developed world, we have the benefit of what's called a cold chain. From the time your produce is picked, it can basically be transported at refrigerated temperatures all the way through until it gets into our homes. And that's a way of buying yourself more time, putting a little bit of a pause on the clock. But all that takes energy. 80% of our fresh water goes into agriculture.
Because food is so energy intensive, that means the food system is an opportunity to save energy or to avoid energy consumption. And we could do that with our personal choices of what we eat, where it's from, how much we serve, and what waste we have. We can also get there with better markets, better policies, and better technologies that manage the system more effectively so we have less waste and fewer inputs along the way.
We wanted a chance to look at this in a different perspective. From my perspective as a chemist, I see the whole world as a beautiful catalog of chemicals. And so it's about looking to those same inert building blocks that our bodies are trained, to eat and consume, and taking that inspiration from nature in order to build the platform for our technology.
We could take the same ingredients and the same components that exist in nature that are already forming the peel on a piece of produce and reinforce those. And so to apply a little bit extra of this peel, we can actually slow down the respiration rate of the fruit and give it a little bit extra shelf life so we have more time to use it in the way that we thought we would.
We're collecting all the volatiles that are coming off of the avocado and analyzing them to determine things like fruit quality.
Our product itself is a powder, but it's dispersed in water. So we spray it on, and then you just need time for that produce to dry to leave behind that protective layer.
There's a lot of different ways that we can measure the shelf life of the produce. One way is visually, and so we have these time-lapse rooms.
And what it allows us to see is really just how that produce is able to retain moisture for longer due to the protective benefits of the Appeal product.
Our global supply chain brings us citrus any time of the year because they're always in season somewhere. Because of energy, we might bring together fruits and lettuce from South America, nuts from North America, spices from China, and meats from Europe, all just to meet our preferences. And energy-enabled transportation is so swift and cheap, we don't notice the distance the food has traveled.
The local food movement has risen up partly in response to this industrialization and also because of concerns about the environmental impact about how far that food has traveled. There's a lot of energy that goes into trucking or training or shipping food long distances. But it's not always better for the environment, and that's a surprise for many people.
In Great Britain, it takes an enormous amount of energy to raise something like lamb. So if you're shipping it from overseas, that might seem like the transportation costs are really high, but it's more energy intensive to eat local lamb.
There are a lot of reasons to shop locally for food, but it's not always better for the environment.
Japan is an island nation and a very mountainous island nation. It actually has about 95% of mountainous regions. So, it's a very land-limited country overall. Vertical farming is a relatively new phenomenon. We use sort of a hydroponic system, which means that we don't use any soil, but we also take it indoors. Vertical farming takes all the factors that a plant needs, lighting, the nutrients, temperature, and humidity, and refines all those. And it's able to produce that environment every single day of the year, consistently producing crops anywhere in the country at any day of the year. Japan is a country made for this kind of technology. We're one of few very large-scale sort of commercial production vertical farms worldwide. We produce 21,000 heads of lettuce every day. When you look around the world, there are areas, including North America, where they're distant from the market. Bringing that closer to the market is one potential application of this technology. Certainly, this is one sort of solution. So that is not to say that it's a sort of technology that will overtake all of agriculture. It's just sort of one potential solution to add to the mix of solutions for agriculture moving forward. Theoretically, you could take this as far as space.
I think part of the situation that we're in is that the invisibility of the processing of food. When I was growing up in India, everything was very intimate. You knew every step of the process. To me, it's a kind of sensitivity. You know, how do we bring back that sensitivity to what we're using? When I was doing my research, I noticed one day there was all this commotion outside the balcony of my apartment, of my flat. And I went outside and I looked over, and there was a refrigerator coming in. Prior to the refrigerator, every woman would cook an extra serving of food for every meal. Now you have to remember, before refrigeration, in that kind of heat of Tamil Nadu, of South India, you know, food went to waste very quickly. And so around the time of after breakfast or after lunch or after dinner, so the beggars would come and then that excess food would be given to them. A few days later, I noticed a beggar coming to the door. And the woman, she says to this beggar, "Choo-choo, go away. We don't need you anymore." So I think even the refrigerator coming radically shortened the moral imagination of that woman. Now, of course, I don't want women to have to work, 12 hours a day to cook 3 meals, and there's a great oppression in that. But we need to be very, very conscious of the perception of actual need and constructed need and excessive need. There's a hope in me that we could reimagine our sense of energy.
So fossil fuels give us a density of energy that helps us get density of food production. It also creates a density of environmental problems. So we have this ability to ramp up on our productivity of the food system from these industrialized fossil fuel inputs, but also creates other problems we have to manage.
The revolution in food production, which of course has been very, very critical globally. Let's now project forward, say the mid-century, and aspire to developing countries being raised up and having the kind of protein intake that we are accustomed to.
Throughout our lifetimes, human population on this planet will have tripled. But the natural resources to feed these people will not have tripled. We will not have 3 times more water, land, fertilizer, and so on. If we were to forego livestock, let's say, we would forego the use of 2/3 of all agricultural land. And I don't think anybody can want that. So what we can do is we can help other countries to achieve similar increases and improvements in efficiencies as we have.
We become very disconnected from the food system. So we've lost the touch with the agricultural system that grows the food in the end.
The important thing to keep in mind is that we have a stake in deciding this. We choose where we shop, we choose what kind of foods we're going to buy, how to eat it, how to dispose of it. We have choice all up and down the food system, and those choices ripple through and have big consequences for our energy consumption, but also land use, water use, and environmental impact. It's not predetermined. We can choose our future.
Energy and food are synonymous, as the food system requires energy, and food is a form of energy for our bodies. Modern forms of energy such as diesel, natural gas, and electric refrigeration gave us a food revolution, allowing us to feed more people with fewer farmers, but leading to more food being wasted. Changing our relationship with food by wasting less and changing what we eat could have profound effects on the energy system. With the right combination of policies, new innovations, and technologies, we should be able to increase the food supply for everyone while reducing energy required to make food.